In this session, we will take a look at relative speed, another very important concept in time and distance. So, what is relative speed? Relative speed is nothing but the speed of one body with respect to another body or relative to another body. It is best understood by taking an example of two people A traveling at a speed of 10 km per hour and B who is traveling at 12 km per hour. When A and B travel in the same direction, then in the first 1 hour, because B is traveling faster than A, B will be 2 kilometers ahead of A. Similarly, at the end of the second hour, B will be ahead of A by 4 kilometers. And similarly, at the end of the third hour, B will be ahead of A by 6 kilometers. Thus, every hour we can see that B goes ahead of A by 12 minus 10, that is 2 km per hour. This 2 km per hour is known as the speed at which B travels relative to A, and therefore this is also the relative speed between A and B. So relative speed between B and A here is 2 km per hour. We can generalize now. If two bodies are traveling in the same direction, then relative speed must be the difference of the two given speeds, which in this case is 12 minus 10, that is 2 km per hour. Similarly, when two bodies are moving in opposite direction, the relative speed is nothing but the sum of the two given speeds, x plus y. So in the previous example, relative speed will be 10 plus 12, that is equal to 22 km per hour. We may note here that relative speed comes into picture only when two bodies are in motion simultaneously. If there is only one body which is moving, there is no question of relative speed. Let us look at the first question based on relative speed. A bus starts from point X at 6 am and travels towards point Y at a speed of 60 km per hour. A car starts from X at 8 am and travels towards Y at 80 km per hour. When will the car catch up with the bus? In order to solve this, let us draw a schematic representation of the above situation. We have a point X and we have a point Y. Both the bus and the car start from point X. Then there is a point Z, because for the first 2 hours the bus is traveling all alone. And because the bus is traveling all alone, there is no question of relative speed till 8 am. And the bus travels from the point X to the point Z from 6 to 8 am, that is in 2 hours. So let us first see what is this distance xz. So if the bus starts at 6 am, the bus reaches at z by 8 am. The distance xz must be simple speed of the bus into the time 2 hours, that is equal to 120 km. At 8 o'clock, the car also starts moving, and the moment the car starts moving, we will have the relative speed into picture, because the relative speed will come into picture at 8 am when the car starts moving. And this distance xz, which this 120 km, is the relative distance between the car and the bus. So we say the relative distance between the car and the bus is 120 km. Both the bodies, that is the car and the bus, move in the same direction. So the relative speed between the two bodies is 80 minus 60, that is equal to 20 km per hour. So what is the time after which the car will catch up with the bus? The car will catch up with the bus after a time that is equal to the relative distance divided by the relative speed. Because we have taken relative distance in the numerator, we need to take relative speed in the denominator here. So what is our answer? 120 divided by 20, that is 6 hours. So the car will catch up with the bus after 6 hours. But 6 hours after what? 6 o'clock or 8 o'clock? It is 6 hours after 8 o'clock. That is when the car starts moving. So obviously the car will catch up with the bus after 6 hours after 8 a.m., which is basically at 2 o'clock in the afternoon. Let us take a look at another example. A thief sees a policeman 150-meter away and immediately starts running away from him at a speed of 10 km per hour. After 1 minute and 12 seconds, the policeman spots the thief and starts running after him at a speed of 15 km per hour. What distance will the policeman run to catch the thief? Again, let us first of all draw a schematic representation of the question. So let us start with a schematic representation of the above question. So we have A, B, C and D 4 points. The thief is initially, the policeman initially is at A and the thief initially is at B. And this distance is 150 meters because when the thief sees the policeman is 150 meters away. As soon as the thief sees the policeman, he starts running in the opposite direction, and therefore thief must be running towards the point C and D, and after 1 minute and 12 seconds he reaches the point C, and this is the point when the policeman spots the thief. So when the policeman spots the thief is at point C. So let us try to calculate this distance BC, because it is important to calculate the distance BC to know what is the relative distance between the policeman and the thief. So the speed of the thief, which is 10 km per hour, when converted into meters per second, is 10 into 5 by 18, which is equal to 25 by 9 meters per second. Similarly, the speed of the policeman, which is 12 km per hour, when converted into meters per second, yields 12 into 5 by 18 is equal to 30 by 9 meters per second. So, in order to calculate the distance BC, we multiply the speed of the thief ST into 72 seconds, because 1 minute and 12 seconds is equal to 72 seconds. So speed of the thief multiplied by 72 seconds is equal to 25 by 9 into 72 seconds, which gives us 200 meters. So the distance BC, as you can see on the schematic representation, is equal to 200 meters. So after 72 seconds, when the policeman spots the thief, the thief who is at C is basically 150 plus 200, that is 350 meters away from the policeman. So in order to calculate the time after which the policeman catches up with the thief, we need two things: the relative distance and the relative speed. We've already calculated the relative distance between the policeman and the thief. And what is the relative distance? It is the distance between the policeman and the thief when the policeman just starts running towards the thief. So this is equal to 350, which is the relative distance. We have already calculated this. And what is the relative speed? Because the policeman is running after the thief, the relative speed between the policeman and the thief is 30 by 9 minus 25 by 9, that is equal to 5 by 9 meter per second. So what do we get? The required time is 350 divided by 5 by 9, which is equal to 630 seconds. But this is not yet our answer. We are required to calculate the distance that the policeman will run. So basically we need to calculate the distance that the policeman will run in these 630 seconds. So what is the distance? Distance D is equal to 30 divided by 9 multiplied by 630, that is equal to 2100 meters, which is 2.1 kilometers. A pretty long distance. So let us take a look at another question based on relative speed. A bus starts from a point X at 6 am and travels towards Y at a speed of 60 km per hour. A car starts from Y at 8 am and travels towards X at 80 km per hour. When will the car catch up with the bus if the distance between x and y is known to be 540 km? Again, let us draw a schematic representation. We have x, we have z, and we have y. X and y are the two endpoints. The bus starts from x and the car starts from y. Bus starts at 6 a.m. and the bus reaches at z by 8 a.m. You will remember that till 8 a.m. there is no question of relative speed. Relative speed will apply when the second body, that is the car, starts moving. So let us first calculate what is the relative distance between the car and the bus at 8 a.m. In order to do that, we need to calculate the distance xz. So what is the distance xz? The distance xz must be the distance traveled by the bus in 2 hours, which is equal to 60 into 2, that is 120 kilometer. So at z, the bus is at z and the car is at y when the car just starts running. So the relative distance between the car and the bus must be the distance zy. So what is the distance zy equal to? The total distance between x and y, that is 540, minus 120, which is equal to 420 kilometer. This is the relative distance between the bus and the car. Now, relative speed in this case, because the two bodies are traveling in opposite direction, the bus and the car, that is, they are traveling in opposite direction. Therefore, the relative speed will be the summation of the two speeds, and we have 80 plus 60 is equal to 140 kilometer per hour. That is the relative speed between the car and the bus. So the time taken, we know the formula already, is equal to relative distance divided by relative speed. What is the relative distance? Is equal to 420. What is the relative speed? It is equal to 140, and 420 by 140 gives us the time taken, that is equal to 3 hours. And this 3 hours will be counted from the time when the car starts running, that is 8 a.m. So when will the car catch up with the bus? The car will catch up with the bus at 11 a.m. So with this, we come to an end of this session. If you have any query or any feedback, please feel free to contact us at studentservices@pfindia.com. Thank you very much.